youngsters, how are you all? Welcome to the maths class. Students, as we have started with the topic of maxima minima yesterday, so today we are going to proceed further with the same. Now question number 3 of your exercise 6.5 is find the local maxima and local minima if any, that is if exists, for the following functions, and also find the value of local maximum and local minimum. So your first case is f of x is equal to x square. So to find the local maxima or minima, first thing we are going to do is to find their first order derivative. Then we put that first order derivative equal to 0. Whatever the value of x comes out to be, that will be our critical points. Then we are going to find the second order derivative of the same function and the value of the second order at that point. If it is positive, then local minima. If it is negative, then local maxima. So here x square first derivative is 2x. When we put it equal to 0, x is equal to 0. So second order derivative comes out to be 0. So which is a positive value. So that means we are getting the local minima at x equal to 0 and its value is 0. Now the next second part of question number 3 is g of x is given by x cube minus 3x. So we will find first order derivative, that is 3x square minus 3. When we put first order derivative equal to 0, we will get x as plus minus 1. Now this plus minus 1 will be our critical points. Next step is to find its second order derivative. When we find its second order derivative, that is 6x. When we put x as 1, we are getting the value of second order derivative as 6. When we put it as minus 1, we are getting the value as minus 6. Now 6 is greater than 0. So that means at 1 we are getting local minima. At minus 1 its value is less than 0. So this implies we are getting local maxima. Next is to find the values. We always calculate the values from the function. So we will put x is equal to minus 1, which will give us local maxima, and at x equal to 1 we are going to get local minima. Next the third part is function hx is given by sin x plus cos x, where x is lying between 0 and pi by 2. Now first we will find the first order derivative. So sin x derivative is cos x and cos x derivative is minus sin x. Next we will put the derivative equal to 0. So when we put the derivative equal to 0, we are getting the value as sin x equal to cos x, which implies tan x is 1. When tan x is 1, at x equal to pi by 4. Clearly this pi by 4 belongs to our interval, that is 0 to pi by 2. Next is to find the second order derivative of the same. So second order derivative comes out to be minus sin x plus cos x. So when we put x as pi by 2 here, we are getting the value negative. That means it has local maxima at x equal to pi by 4. Now next the fourth part is fx is given by sin x minus cos x and x lies between 0 to pi by 2. First we will find its first order derivative, sin x cos x and cos x minus sin x. So f dash x reduces to cos x plus sin x. Next step is to put first order derivative equal to 0. So this implies cos x is equal to minus sin x, or you can say tan x equal to minus 1. So tan take minus 1 between 0 to pi by 2 at two values, that is 3 pi by 4 and 7 pi by 4. So we will put both the values in its second order derivative. First we will find the second order derivative. Second order derivative is minus sin x plus cos x. At 3 pi by 4, its value is minus root 2, which is negative. That implies it gives the local maxima. Next at 7 pi by 4, its value is positive. That means it will give the local minima at x equal to 7 pi by 4. Next is to find the values at these 2 points. So at x equal to 3 pi by 4, we are getting the value as root 2, and at 7 pi by 4 we are getting the value as minus root 2. Students, next fifth and sixth part I am giving as a homework to you. Do try these two parts similar to the first 4 parts as we have done. That's all for today, students. Do revise the today's topic, plus do your homework also. Take care and have a great day ahead.